Hi everyone. I'm still a bit worried that you might have some confusion for the tutorial. So let's have a look on the tutorial question. So for the first question is about a vapor compression refrigerator. I change it to R14, I think 134A as the refrigerant. Why? Because so that you can easily to refer to the thermodynamic, the Chenko, the thermodynamic set temperature and pressure table. So it's operate between 2 bar and 12 bar. So the compression is isentropic and there's no undercooling in the condenser. The vapor is dry saturated condition. At the beginning, estimate the COP. Okay, we have a look on the A first. So I think I have shared with you my handwriting. So let me simplify this. It will be easier for everyone. So for the first one is the dry saturated condition at the beginning of the compression. So if you refer to your textbook, your lecture notes, from the saturated, it will definitely go to the superheated. And then it go to the saturated curve, and then it go to number 3. So this is the curve, all right? So we check whether this is right or wrong. So we refer to the table of A12, okay? Let's check it out, A12. Sorry about that. Let's check it out. Okay, if you refer to table 12, all right, definitely for 0.4 and 1 is 2 bar. So if you convert to kilopascal, it's 200 kilopascal. So this point is Hg, okay? So let's have a look. The Hg is 224.46 if you refer to this one, okay? So, and if you refer to the textbook, no, not the textbook, the reference book, okay? So the S1, you no need to refer. It's really TS. S1 equals to S2. So you can use the H1 SG at 2 bar, okay? SG as 2 bar, 0.393773. This one is also equals to S2. So, but S2 is at 12 bar. So you refer to 12 bar, which is 1,200, yeah, 1,200. So if you refer to this one, the S is 0.91303. So which is, this value is much larger than, S2 is much larger than SF at 12 bar. So it's proven that this is as superheated. Okay, so then we refer to H3 because H1, 0.1 and 0.3 is the easiest one because they are located at the saturated curve. All right, so you just refer to 12 bar, 1200 kilopascal, HF, okay, 1200 HF. So HF, okay, this column. Oh, I think it's this one. Is it? Let's check. Yeah, this one. Okay, it's 117.77. Can you see that? So, and if you refer to the pH diagram, H3 is equal to H4. Please refer to your lecture notes. So therefore, you can have your H3 equals to H4 equals to 117. Does that make sense? So sebab H2 ialah superheated lah, right? So then we have to refer to table A3. So how to get the H2? Then we just use these methods to get your H2. Try it, you get it, okay? how, then you just refer to use this value, find the closest at 1.2 bar. So it should be this part. Can you see that? So the nearest is this one, these two. Okay, then you just use the technique to find it. So the refrigerating effect is actually at evaporation part. I think it's better. Yeah. So H1 minus H4. So you found your H4, you found your H1 just now. So you just plug it in. The work done is at the compression part, which is this part. So you just plug in everything, then you can get your COP. Okay, then the next one is compression is isentropic with undercooling in condenser. So I'm sorry about that. I forgot to mention about the delta T. So let's us put it as still 10 degree, drop 10 degree, 10 Kelvin. So then you refer to 12 bar, okay? Because it's at the saturated curve, so we refer to the saturated table. So because this line is at the above line, we still stick with 12 bar. So the 12 bar is 46.29 Celsius. So, but it's dropped 10 Kelvin. So we convert this as Kelvin minus 10 Kelvin is, then you convert back to Celsius is 36.9. Then you use 36.9. So your temperature is 36.9. Then you use a 36.9 and then you find your H3. So I have the answer, but I have the step, but I think you can get it. So then you put the H1 minus H4 to get the refrigerating effect, and then you can get your COP. All right, is that okay? Okay, so let's look at the second question, R32. Is used in a vapor compression refrigerator. The pressure before entering compressor is 1.21 bar. So the maximum is 12.44 bar. So what else? Dry saturated vapor delivered to the condenser. So at 2.2 is dry saturated vapor. All right. So this is Hg or Sg for 0.2, right? So in order to achieve that, if you refer to the lecture notes, the number one is a mixture, right? A wet vapor. So, and just now your friend asked me, how can I get the X? So I'll show you later. So calculate the refrigerating effect and the COP system. So first we click on this link, okay? I couldn't find it in our textbook. The reason is this is the latest refrigerant in the market. So I have one of the aircon at home that using R32 with Panasonic brand. I'm not going to promote that, but anyway, this is the latest one, all right? So let's have a look at the table. The table is slightly a little bit funny because they use the comma to represent the point. But if you look at the questions, you should know that 12.445. So then, or 1.2163. 1.2163 is definitely is a point rather than it's a comma, right? So then we draw the TS diagram first. So we know that the H2 is Hg. So this is what I have it here. So 12.445. 12.445 is here. So the H, you have to be aware of this. So at this point is vapor. So 12.445 is the vapor. So it should be 516.9. All right. And we know that S1 equals to S2. So I can use my S2 to get my S1. Does that make sense? So therefore, I can use my S2 2 at temperature of, at pressure of 1 point, what's that? 1.2163, okay, to get my H1. Okay, I don't need to find the X. All right. If you want to, yes, but you don't need it. So for the refrigerating effect is H1 minus H4. So since you have your H1 at the, where's your H1? So since you have the H1 here, the H4 equals to H3. You can refer to your lecture notes why this happened, okay? So for the work done is always 1 to 2. So you just plug in the value here, then voila, you can get your work done. And you know that the Q1 over work done is your COP. So then you can get your answer. So I hope now you can understand the tutorial. So I hope see you soon. All right, stay safe everyone. Don't jalan-jalan cari makan now. Right, bye.